Good evening, beta. Let us try to do some problems on ray optics. Here's the first problem, beta. See here. A point object is moving on the principal axis of a concave mirror. Of focal length 24 cm. What is the question? Point object is moving on the principal axis of a concave mirror of focal length 24 centimeters towards the mirror. When it is at a distance of 60 centimeter from the mirror. Okay, its velocity is 9 centimeter per second. Tell me what is the velocity of the image at that instant. Sure, try to do it. Point object is moving on the principal axis of your concave mirror. So this is your concave mirror. Is silvered on the outer side. Okay, and here there is an object. Object is moving with a velocity. Velocity of object is equals to 9 centimeter per second. And object distance is u is equals to your 60 centimeter from the pole of the mirror. And focal length of the mirror is equals to your concave cavity minus 24 centimeters. Okay. So is asking the velocity of image. What is the formula for velocity of image, beta? Can anyone? Velocity of image in terms of magnitude, if I'm taking, is equals to v square divided by u square into your velocity of your object. Done. Object distance is there. Focal length is there. I don't know the image. I can calculate the image by using the formula. V is equals to u into f divided by u minus of your f. Sign convention. All the distances are to be measured from the pole of the mirror. So object distance is minus 60 into focal length is minus 24 divided by object distance is minus 60 minus focal length is minus 24. Done, beta? Okay. So this value will be equal to how much for me? Minus minus will be plus. So it is 60 into 24 divided by minus 60 minus minus plus minus 60 plus 24. It will be your minus of your 36. Done, beta? This is 10, this is 6, isn't it? 6 1s, 6 4s, 24. So this will be equal to minus of your 40. So V will be equal to minus 40. So from this one, I can use this formula. Velocity of your image is equals to V square divided by U square. So it is equals to velocity of your image will be equal to v by u whole square. So it is minus 40 whole square divided by minus of 60 whole square into velocity of object is 9. So this 0 will get cancelled. So this will be 2 by 3 whole square into 9. So this will be 4 by 9 into 9. 9 gets cancelled. So this value will come out for me 4 centimeter per second. समझ लिया बेटा? चलो next question. Ray of light propagates from glass. The bracket of refractive index of glass is 3 by 2. To water, refractive index of water is 4 by 3. Okay. The value of critical angle is Chalo, tell me. Ray of light is propagating from glass to water. Like say for example, if I am taking two medium, this medium is say for example glass, and this medium is say for example water. Refractive index of water is 4 by 3. Glass is right now for me 3 by 2. So ray of light is going from this medium, it bends away from the normal. So this will be the angle of refraction. This will be the angle of incidence I. Done. Now for the critical angle, you know that sine of your C will be equal to refractive index of rarer medium divided by refractive index of denser medium. Rarer medium will be equal to water 4 by 3. Denser medium will be equal to 3 by 2. So that is equals to 4 into 2 divided by into 3. 4 2 is 8, 3 3 9. So critical angle will be C is equals to sine inverse of your 8 by 9. This will be the answer. Next question. A convex mirror has a radius of curvature of 22 centimeter. Okay. If an object is placed 14 centimeter away from the mirror, 14 centimeter away from the mirror, then its image formed at, चलो करो जल्दी से, कॉन्वेक्स मिरर है बेटा. कॉन्वेक्स मिरर के लिए फोकल लेंथ क्या हो जाएगा? पॉजिटिव. रेडियस ऑफ कर्वेचर इज गिवन हाउ मच फॉर मी? 22 centimeter. And focal length of this one will become how much for me, beta? Focal length will be equal to how much for me? Radius of curvature r is equals to 2 times of f. F is equals to r by 2. That is 22 divided by 2. That will be equal to 11 centimeter. Done. Convex mirror has curvature 22. If an object is placed 14 centimeter away from the mirror, then where its image is being formed? Object distance is minus of 14 centimeter by V plus 1 by U is equals to 1 by F. Done. So we need to calculate image 1 by v plus object distance is equals to minus 14, that is equals to 1 by 11. Yeah. So from this one you can calculate the image. I hope you can do care of that calculation. Done? I had disabled the chart option better. Chill. Next question. A square of side 3 centimeter is placed at a distance of 25 centimeter from a concave mirror. Of focal length 10 centimeter. Okay. The center of the square is at the axis of the mirror. At the axis of the mirror, and the plane is normal to the axis. The plane is normal to the axis. Okay. The question is the area enclosed by the image of the wire is. A square of side 3 centimeter is placed at a distance of 25 centimeter from a concave mirror of focal length 10 centimeter. The center of the square is at the axis of the mirror and the plane is normal to the axis. The area enclosed by the image of the wire is. The area enclosed by the image of the wire is. देखो ये मेरे पास मिरर है, कौन सा मिरर? कॉनकेव मिरर, सिल्वर ऑन द आउटर साइड, और इसके सामने वी आर हैविंग स्क्वायर, ऐसा कुछ स्क्वायर है विद इट्स एक्सिस पासिंग थ्रू द सेंटर, एंड एक का डिस्टेंस कितना है मेरे पास? डिस्टेंस ऑफ 25 सेंटीमीटर, साइड इज गिवन एज 3 सेंटीमीटर, ठीक है ना? और इसका ऑब्जेक्ट जो है फ्रॉम द पोल ऑफ द मिरर इज एट योर 25 सेंटीमीटर, और ये इसको फोकस है, फोकल लेंथ इज गिवन फॉर मी, यहाँ से यहाँ तक इसको फोकल लेंथ इज गिवन एज ऑफ योर 10 सेंटीमीटर, ठीक है ना? कॉनकेव मिरर है तो ऑब्वियसली फोकल लेंथ विल बी इक्वल टू माइनस ऑफ 10 सेंटीमीटर, ऑब्जेक्ट डिस्टेंस इज इक्वल्स टू माइनस 25 सेंटीमीटर्स. ओके, एरिया इनक्लोज्ड पूछ रहा है, isn't it? पहले इसका इमेज कहां पर गिर रहा है वो देख लो. 1 by v plus 1 by u is equals to 1 by f, isn't it? So इमेज निकालना है तो 1 by v is equals to ऑब्जेक्ट डिस्टेंस इज माइनस ऑफ 1 by 25, माइनस मतलब उधर चले जाएगा तो प्लस, ऑब्जेक्ट डिस्टेंस इज गिवन, फोकल लेंथ ऑलरेडी है तो इट इज माइनस ऑफ 10 plus this will become for me equal to minus minus. Either plus है ना बेटा, object distance is minus. So if it is going there, it will become for me plus, that is 1 by 25. Done. So from this one you can simplify the image. 1 by v is equals to, LCM will be equal to 50. This will be equal to 5. This will be equal to plus 2. So this will be, from this one I'll get image v is equals to 50 divided by 3 minus sign. So image distance is equals to minus of 50 divided by 3. Done. चलो इसका मैग्निफिकेशन निकालते हैं नेक्स्ट. Magnification is equals to minus of your v by u, isn't it? So that is equals to minus of 50 divided by 3 divided by object distance. Object distance is minus 25. तो मैग्निफिकेशन कितना आएगा बेटा? m is equals to 25 1 जा 25 2 जा, यानी minus of 2 by 3 is its magnification. है? Once I know the magnification, now I need to calculate the area enclosed by the image. Area enclosed by the image मतलब क्या हो जाएगा? Magnification को जो है ना, multiplied with your d times area. So it is magnification into your distance, यानी इसका जो width है ना side, उससे multiply करो. So this will be equal to, magnification is 2 by 3 into side is 3. So this value will become for me 2 centimeters. Isn't it? So area will be equal to how much? Area will be equal to your m square. That will be equal to 2 square. That will become for me 4 centimeter square will be the area. Okay. Sure. Sure. Next question. find the position of the final image from the mirror. If x is equals to 10 centimeters and t is equals to 3 centimeters. Okay, this is the situation given. The slab, and it is silvered on one side. Okay, and object is in front of this one. This is your x. This is your t. Okay. Find the position of the final image. See, the object will first touch the slab, then mirror. Again from mirror it reflect back and come back to the slab. So the way the light will go is first it will touch the slab, then it will touch the mirror. As it is a plane mirror, it gets reflect back. So again it comes back to the slab. If I'm talking about for slabs, I already told you when object is in front of the slab, so S will be equal to T into 1 minus 1 by X. So thickness is given as of 3 into 1 minus X is also given as 3. So that will come out for me how much? 1 centimeter. Done? Sure. So for slab, the shift will be equal to how much for me? 1 centimeter. Okay. Then for mirror to slab, then again shift will be equal to T is equals to T into 1 minus 1 by X. That is equals to 3 into 1 minus. Now, this will become how many times beta? X value will become how much for me? Mirror it is reflecting exactly. So this value will become for me how much? If X is equals to your 10 centimeters and thickness is right now for me 3. Okay. This value will become how much for me? 2 by 3. So that will be equal to 1 centimeters. So total distance of the final image will be equal to 12 minus 1. Then, so that will be equal to your 11 centimeters. Some of the students are asking for aerial magnification formula beta. I'll write to you that formulas. You know, magnification, if I'm writing axial magnification, will be equal to height of image divided by height of object. Or that is equals to V by U whole square. Or that can be also written as of your M square. Or that can also be written as of your F divided by F minus of your U whole square. Or that is equals to your F minus V divided by F into your whole square. Done. Like say for example, this is your axis, and in front of this axis there is a object. So height of the object is h naught and width of the object is w naught. If I'm talking about its magnification, this is right now for me magnified part. So its image will become for me, width of the image will be equal to m times the width of the object, and height of the image will be equal to m times the height of object. This is known as of your aerial magnification. Done. And see for some theoretical questions beta, magnification formulas, if I'm writing m is equals to height of image divided by height of your object, that is equals to minus of your v by u, transverse element, or that is equals to f divided by f minus u, or that is equals to f minus v divided by your f. Okay, in this one, if mad of your m is greater than 1, okay, then the image is enlarged. Image is enlarged. Okay, in the same way, if magnitude of your image is equals to 1, if you are getting exactly, then the image of same size. Then the image is of what? Same size. In the same way, if mod of your m is lesser than 1, then in this case the image is reduced. The image is reduced. Done. If your magnification is greater than 0, if magnification is greater than 0, the image is erect. The image is erect. Okay. If magnification m is lesser than 0, the image is inverted. The image is inverted. These are the basic things which you need to keep in the mind better. I'm talking about this one. Magnification is greater than 1, what happens? Magnification is 1, what happens? Magnification lesser than 1, greater than 1, and lesser than 1 part definition. In this case, the image is enlarged. In this case, the image is of same size. In this case, the image is reduced. In this case, the image is erect. And if it is lesser than 0, the image is right now for me inverted. Done? Sure. One more good question, Beta. Consider the situation shown in figure. Okay. We got a plane mirror. Plane mirror is fixed at a height, fixed at a height of 30 centimeter, okay, above the bottom of a beaker, above the bottom of beaker containing water. Refractive index of water is 4/3, okay, up to a height of 12 centimeters, okay. The same way, consider a point at the bottom, consider the point at the bottom of beaker, okay, and find the position of image of capital A formed by mirror, okay. This is a given diagram, okay. And here there is a mirror, there is water filled in this one, to this one. This is a point here right now, somewhere at your A. This distance is given as of here 12 centimeters. And the mirror is kept from the point A at a distance of your 30 centimeters. So consider the situation is shown in the figure. A plane mirror is been fixed at a height of 30 centimeter above the bottom of the beaker containing the water up to a height of 12 centimeters. So in this one there is a water up to a height of your 12 centimeters. Consider a point at the bottom of the beaker and find the position of the image formed by the mirror. Done. See, when you're seeing from the upper part, this object appears to be raised now beta. This point A will appear to be somewhere here. That means from the surface, we'll be seeing the apparent depth. So that apparent depth will be equal to how much for mu beta? You know that apparent depth H dash is equals to capital H divided by mu. Actual height is right now for me 12 divided by refractive index of that one. Isn't it? So I can say that distance of the image. So if there is an object here right now, isn't it? Now, what is the distance of your image? I can say, you tell me right now. So distance of the image from the position of your A, from where it is been formed. So can you tell me what will be the position? This is some point. This is the image beta I, and this is your P. So P to I is right now for me right now 12 by mu, isn't it? So that will be equal to your 12 divided by mu. Mu is equals to 4/3. So it is 12 into 3 divided by 4. So that will be equal to 9 centimeter. That means distance of your image I from the mirror will be equal to how much? Now tell me, what is your distance of your image I from mirror? From mirror, I'll draw that one. From here to here, this distance I'm talking about. This distance. So can you tell me what will be that distance, anyone? It will be total distance is right now 30, isn't it? Minus, I need to do minus 12, then plus 9. That will be equal to 27 centimeters. So can I say that position of the image of your A from the mirror will be equal to how much? So I can say that image of I is formed at a distance of 27 centimeters. The distance of 27 centimeters behind the mirror.